Now let's come to the exercise 2.4 NCERT textbook question number 4. Find all the zeros of a polynomial which is a biquadratic polynomial, and if two of its zeros are given, 2 plus minus root 3. So the two zeros are here, alpha 2 plus root 3 and beta 2 minus root 3. So we have to get the divisor by using the formula x square minus sx plus p, x square minus s 2 plus root 3 plus 2 minus root 3 into x plus 2 plus root 3 into 2 minus root 3. As we know that the sum is given by alpha plus beta and the product is given by alpha into beta. So alpha plus beta, alpha into beta. So minus root 3 plus root 3 cancels. X square minus 4x. A plus b into a minus b, a square minus b square. It becomes 4 minus 3. So x square minus 4x plus 1 will be our required answer now. Now here we divide the given polynomial x to power 4 minus 6x cube minus 26x square plus 138x minus 35, and our divisor is x square minus 4x plus 1. So x to the power 4 upon x square, we get x square. So x square, x to the power 4 minus 4x cube plus x square. So change the sign, cancel out, minus 6x cube plus 4x cube minus 2x cube minus 27x square plus 138x minus 35. Now minus 2x cube upon x square, that becomes minus 2x. So second term of quotient minus 2x minus 2x cube plus 8x square minus 2x. Now change the sign, plus minus plus cancel, minus 35x square plus 140x minus 35. Now minus 35x square upon x square, which gives us minus 35. So our third term is now minus 35. Minus 35 into x square minus 35x square minus 35 into minus 4x plus 140x minus 35 into plus 1 minus 35. Now plus minus plus, the whole part will be cancelled and the remainder we will get as 0. Now to get the remaining two zeros of the quadratic polynomial, we have to equate this quotient equal to 0. That is now the quotient q of x is equals to x square minus 2x minus 35. For zeros, q of x will be equal to taken 0. So x square minus 2x minus 35 equal to 0. X square minus 7x plus 5x minus 35 equal to 0. Minus 7 plus 5 minus 2 minus 7 into 5 equals to 1 into minus 35, that is minus 35. Splitting middle term, x common, x minus 7 plus 5 common, x minus 7. Now x minus 7 common, we get x plus 5. So the two linear factors x minus 7, x plus 5. So x equal to 7 or x is equals to minus 5. These are the two remaining zeros, and that all the zeros are, therefore the zeros are 2 plus root 3, 2 minus root 3, 7 and minus 5. So that is your solution. Now question number 3 of exercise 2.4. It is a very important question. If the zeros of the polynomial p of x equal to x cube minus 3x square plus x plus 1 are a minus b, a and a plus b, find the value of a and b. Now clearly from the given polynomial we can see that the degree of a polynomial is 3. So it is a cubic polynomial. So we have to take the relation for a cubic polynomial, the relationship between the coefficients and the three zeros of a cubic polynomial. So this one is the alpha, this one is the beta, this is the gamma. So alpha is given to us a minus b, beta is given to us a, gamma is given to us a plus b, and the given cubic polynomial, p of x cube minus 3x square plus x plus 1. So therefore here we can write down the capital A is 1, capital B is minus 3, capital C is 1, capital D is equals to 1. As while giving the formula, I have given you in the small letters of the coefficient alpha plus beta plus gamma equal to minus b by a. But in this question, these small letters are used in the zeros a, b. That's why in case of the coefficients of a cubic polynomial, I have taken the capital letters. Capital A, coefficient of x cube, capital B, coefficient of x square, that is minus 3, capital C, coefficient of x 1, and the constant quantity capital D equals to 1. So plus beta plus gamma is equals to minus b by a. Here I am going to take a capital minus b by a. So alpha is our a minus b, beta is our a, gamma is a plus b equals to minus b, value of b is minus 3, so minus of 3, value of a 1, so here minus b plus b cancel, 3a equals to 3, value of a equals to 1. Now we comes to the last relation for the product one, that is alpha into beta into gamma is equals to minus b upon a. So alpha is our a minus b, beta a, gamma a plus b is equals to minus d, value of d is 1, value of a is 1, a minus b into a plus b, a square minus b square, minus 1, value of a is our 1, so 1 into 1 square minus b square equals to minus 1. So 1 minus b square equals to minus 1, minus b square equals to minus 1 minus 1, we transpose it, and now minus b square equals to minus 2. So this minus will be cancelled out, so we get b square equals to 2. So value of b, whenever we take a square root, we put a minus plus minus sign, b equals to plus minus root 2. Once again we can see about this problem. It is a very important problem. If the zeros of the polynomial, and it is a cubic polynomial since the degree is 3, and the zeros are a minus b, alpha, beta, a, gamma is a plus b, and here we are going to take the coefficients of a cubic polynomial in a capital letter as the small letters are used in the zeros. So alpha plus beta plus gamma equals to minus b by a, that is the relationship between the zeros and the coefficients of a cubic polynomial. So value of alpha a minus b, value of beta a, value of gamma a plus b. On adding them we get 3a equals to, here replacing the value for b and a, we get 3, value of a is equals to 3 by 3, 1. Now the last one, third relation is alpha into beta into gamma equals to minus d by a. So alpha a minus b into beta a into gamma a plus b, value of d is 1, minus 1 upon 1. So a minus b into a plus b, a square minus b square. Now a value is 1, we are going to substitute this value here. So 1 into 1 square minus b square, that becomes 1 minus b square equal to minus 1. Minus b square equals to this one, we transpose towards the right. So we get minus 1, that gives us minus 2. Both the minus sign will be cancelled out. Next step, b square equals to 2. When we take the square root, there will be a plus minus sign. So the value of b is here plus minus 2.